All right, check the flow. Here we go. This is Geometry, Chapter 4-8. We're talking about triangles, and it's gonna be great. Okay, triangles and coordinate proof, ladies and gentlemen. So, a coordinate proof is the use of a coordinate plane and some algebra to prove geometric concepts. All right, so here we go. We want to position and label a triangle in the coordinate plane. So that one leg is A units long and the other leg is B units long. So here's a suggestion when you're labeling this and placing it on a coordinate plane. Place it on the axes. Now since it's a right triangle, we can put two legs on the axes. So we can put our first point where the right angle is, we can place that at the origin, and then we can place the others along the x and y axis. Now we're going to call this point, we're going to say this is A units long. So our coordinate, our x coordinate is 0 and the y coordinate is A. That way this length right here is A units long. Okay, we're going to do the same thing with our other point. We're going to place it somewhere on the x-axis. Our y-coordinate is going to be 0, and then this distance right here is B units long. Okay, and then we connect this. Here is our resulting triangle, MNP, with a side of A and another side of B. Placing triangles on coordinate planes. Here we go. We have a few steps. You can follow these every time you do it. We use the origin as a vertex or the center of the triangle. We want to place at least one side of a triangle on an axis. We want to keep the triangle within the first quadrant if possible. That makes it easier to calculate. Use the coordinates that make computations as simple as possible. So use some easy numbers. Alright? So, for example, we want to name the missing coordinates here of this triangle. Well, x is pretty easy because what is that point? Correct, that's the origin, 0, 0. Okay, the next easy one is going to be z. Okay, our x-coordinate is A because this distance right here is A. And then our y-coordinate, since we haven't moved up along the y-axis, our y-coordinate is 0. Now, we know that this is an isosceles triangle, which means that this is congruent to this side. We also know these angles are congruent to each other. That doesn't really help us much to name this, but what else we know? If this is congruent and this is congruent, then y is at the midpoint of this side. So it's halfway since it's isosceles. So halfway to A. So A halves, and then we'll just call this last coordinate B right here. Okay, so our y coordinate is B. And this is halfway to A, since it's isosceles. Alright, write a coordinate proof. We want to write a proof to show that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. Okay, slightly hard to imagine what that looks like, so we will draw ourselves a picture. Looks like this. So that means joining the midpoints of two sides. Okay, so here's one side, and there's the midpoint of one side. Here's the other, and there's the midpoint. And connecting those two, we want to prove that this line connecting the midpoints is parallel to the third line. Okay, so we're going to place the vertex at the origin and label it 0, 0. We're going to use coordinates that are multiples of 2, because remember our midpoint formula, we have to divide by 2. So we want to use numbers that are easy to work with. Alright, so that's why we call this 2a, and up here We don't know this distance right here, so we'll call this B to, well, maybe we'll call this one 2B and then call this one 2C. Alright, since we don't know anything about whether this is isosceles or anything, we need 3 different coordinates. So, we are given that S is the midpoint of AC, and T is the midpoint of BC, right here. We want to prove that ST is parallel to AB. So, let's look at the coordinates of S, and we can find those using the midpoint formula between these 2 points. Midpoint formula, I'm going to take 2B and add that to 0 right here, and then divide by 2. So take those 2 coordinates, divide by 2. Now I want to take the y coordinates, add those, and divide by 2. Once I simplify this, 2b plus 0 is still 2b, divided by 2 leaves me with b. 2c plus 0 is 2c, divided by 2 leaves me with c. So the coordinates of this point are b and c. That's why we use the 2 for these points, because midpoint formula. So we're going to go through and do the same thing for t. Now t is 2a plus 2b over 2, and then 0 plus 2c over 2. So those coordinates, this is my first coordinate is a plus b, and the second one is c. Now this is going to take a little bit more of a stretch. We are going to now use the slope of this line, st, the slope, remember the change in y over the change in x. So c minus c over a plus b minus b. Simplify this. We are left with 0 over a. And 0 over a is a 0 slope. Now we also know that a to b is a 0 slope. So there we go. We have proved that these 2 lines are parallel. Ta-da! There you have it. The Bermuda Triangle is a region formed by Miami, San Jose, and Bermuda. The approximate location of each is shown right here. We want to prove that the Bermuda Triangle is scalene. That means we want to show that every side is a different length. We're going to use the distance formula to prove that. So using the distance formula, we find m to b is approximately 17.33. Distance formula for BP, we find that is approximately 14.96. And distance formula for MP, 15.93. And there you have it, ladies and gentlemen. Since each side is a different length, this triangle is scalene. And that's all for today, folks.